Control Logix Maintainer Certificate, Chapter 7, Interpreting I/O Tags and Devices in a Logix 5000 System. Our objectives will be to interpret I/O module tags and wiring diagram data, and view and edit I/O module properties in a Studio 5000 Logix Designer application. Throughout this course, we'll talk about going to the controller organizer and into controller tags. Let's talk a little bit about what tags are in Studio 5000. In Studio 5000, tags are the same as what you'd call variables in other programs or in mathematical expressions. They're objects that we create to contain numbers or data that describe a thing in the real world. Let's talk about a few specifically. So I've inserted 4 new tags. Each tag is a different data type because it's a different type of thing. In this green push button, I've made a Boolean tag. And that is because a Boolean is 0 or 1, and a green push button you could really only imagine as having 2 states, off or on. So it fits a Boolean data type perfectly. However, bottle count for line 1. That's something where you could imagine a large number in there, but it would always be a whole number. You don't really count halves or thirds of bottles going down a line, and if you have that, you're going to want to correct that situation before you program around it. So I have a double integer data type, which can reach large values but is always whole numbers. Conveyor speed, on the other hand, I could imagine having a floating point in there somewhere. Maybe I want to tell the conveyor to go 50.7 RPM or 50.7%, whatever. That real adds the floating point precision where I don't have to always have a whole number. And stop time, my timer data type. I want to point out the timer data type is a structure. It's a collection of 2 double integers and 3 booleans. And I'll talk about this because when we go to your I/O-defined data types, they will also be structures and collections of different things. But the timer here has 2 double integers, one for the preset, how long the timer will time, the accumulated value, which is how long the timer has been timing, and then 3 booleans for whether the timer is enabled, currently timing, or currently done. Let's use that idea of a structure that makes up a data type to talk about I/O-defined data types. In my controller organizer and in my I/O configuration, you'll notice that my backplane layout has a processor in slot 2, a simulated inputs card in slot 3, and a simulated output card in slot 4, just like my emulator layout. Modules create I/O-defined data structures that allow us to interface with pieces of hardware. That is, this piece of hardware in slot 3, when we insert it in the I/O configuration, produces tags automatically that allows us access into what's going on. So what do we have for slot 3? We have local, that means local in my chassis. Number 3, that corresponds with slot 3. C, I, and O. What does that mean? C, I, and O. C is configuration data, I is input data, and O is output data. If we expand these, we can see that the configuration data for slot 3 is made up of 400 single integers, or is that signed integers? I can't remember. My input is made up of 2 double integers, and my output is made up of 1 double integer. So just like our timer, where we have a collection of different data types that become one data type, the same is true for our configuration data for our modules. This brings us to a distinction that some people find important. It's the distinction between atomic data types and predefined data types. Your atomic data types are going to be like your Booleans, your short integers. I always get that wrong. Your normal ints, dints, and real. And an atomic data type is a simple data type consisting of one piece of data. However, predefined data types are commonly used memory sizes that are already defined in the Studio 5000 Logix Designer application. That would include timers. It's a predefined structure of atomic data types, and our module-defined data like we've already discussed. Those would be predefined data types. Again, atomic is a single simple data type, one element, just like an atom in physics, and a predefined is a data type that uses groups of other types of data. It's important to talk about the module-defined data type formatting, because this is how we figure out which wire goes into which input often. The beginning of the name is the location, a reference to the slot, and the type. Location in these instances are all local. They're contained within my chassis. They could be remote, though, across communications networks, and we'll talk about that later in the course. So location is first. Slot, we see slot 3 and slot 4, just like in our I/O configuration. Type is easy to interpret. That's configuration, input, and output. There could be different types as well. The next group is your member. This is member data 0, member data 1. Could be all different kinds of members inside of here. For example, this one has 600 data members. And finally, when you blow apart any data type that is not Boolean, you get a group of Booleans. So the final piece of formatting in this address is your bit. And to repeat it, we have location, we have slot, we have type, we have member, and we have bit.